All right, good morning, everyone. Today we are going to begin just reviewing all of Unit 7. So, in terms of all of the different types of significance tests and the different confidence intervals that we have done in this whole unit. So, one thing that we're going to focus on today is how to really tell what type of significance tests we need to do. So, we know that there are so many types that we've already learned. We've done one sample proportion, one sample mean, two sample proportion, two sample mean, a paired t-test. We've done the slope regression test and the three chi-square tests. So if I haven't missed any, that's 9 tests total. And yesterday we spent our time trying to figure out what type of chi-square test to do. So hopefully we're pretty solid on that. So we're going to take a look at some other significance tests, just so that we are used to identifying the important information and knowing what type of hypothesis test that we need to conduct. So I have this structure for today. So this is going to be the format. So for each of the following hypothesis testing scenarios, we want to annotate the prompt to determine the type of hypothesis test that applies to the situation. We want to record that in this box here, as well as the hypotheses. Then we want to actually perform the hypothesis test. And then we want to write a conclusion in the context of the problem. So usually when we make our conclusion, we say that we fail to reject the null hypothesis or we reject the null hypothesis. But sometimes we forget to write, and I'm guilty of this as well, we forget to write what does that mean in the context of the problem. If I'm failing to reject the null, what am I actually concluding? So we're going to try to get in the habit of that as well, so that when we get to our FRQs, we are solid on those conclusions. So let's begin with this problem here to figure out what type of hypothesis tests we are doing. So first we have the National Academy of Science reported in 1997 in a 1997 study that 40% of research mathematics is published by U.S. authors. The mathematics chairperson of a prestigious university wishes to test the claim that this percentage is no longer 40. Okay, so we have some percentages going on here. He surveys a simple random sample of 130 recent articles published by the research journalists and finds that 42 of these articles have U.S. authors. Does this evidence support the mathematics chairperson's claim that the percentage is no longer 40? Use a 0.10 level of significance. Okay, so looking at this problem, I see some percentages going on. So that automatically says to me that we are looking at some type of sample proportion. Now, we have two types of proportion tests, a one sample proportion and a two sample proportion. So I need to see how many samples are we taking. Well, it says here that he surveys a random sample of 130 articles, and that's the only time that it says we're taking a sample. So again, since I have percentages going on here, since it's saying 63 or 62 of the 130 recent published articles, that is also a proportion. That would be a fraction. So this is a one sample proportion test. So now I know what the test I'm doing, and I know in sample proportions, specifically at one sample proportion, I use my P in the hypotheses. So my null hypothesis here is that P is going to be equal to, and this is P is the population proportion. So I know that I have to look at the overall percentage or fraction from the total population. and that is this 40% here. So P is equal to 40%, and then our alternate hypothesis is that P is not equal to 40%, since it says they claim that the percentage is no longer 40. So it could be greater, it could be less than, it's just simply not equal to. So now let's go ahead and extract the rest of the things given to us in the problem. So I know, let me zoom in a little bit here. So I know that my population proportion is 40%. I need my p hat, I need my statistic. So it said that we found 62 of the 130 authors were US. So that's my sample proportion here. That's going to be my statistic. So let's just crunch that out into a decimal. Let's put both of these in decimal form. And then I have my sample size is 130. So note that I didn't put the sample size, my n, as 62. I put this as 130 because n is the total sample that I've taken. So this is everybody that we are surveying, not just the people who are US authors. So my total sample size is 130. Now I'm using a one sample proportion test, and I know that proportions are, we use z's as our test statistic for proportions. So I know that my formula, my general formula is my test statistic is equal to my statistic minus the parameter over the standard deviation of the sample. So in this case, again, since this is a proportion, my test statistic is going to be equal to a z. I can't forget this part here. And then my statistic is whatever comes from the sample. So we have the 62 over 130, so that was the 0.48 is my statistic, minus 0.4, since that is my parameter. That's the value that comes from the population. And then in my denominator, now I need to be careful here because a lot of people made this mistake on their Unit 7 test, and this was what value they used in their denominator. So we know that in a sample proportion, our formula for the denominator is P times 1 minus P over N and the square root of all of that. A lot of people were making this mistake where we were putting p hat in our denominator. We do not want to use p hat. The denominator's formula says p. So if I have p, I should use it. There are some situations, specifically in our confidence intervals, where we might not have the population proportion. And so in that case, we would use p hat in this formula here, but really only for the confidence interval if we do not have the population proportion. So in this case, since I have p, I want to use it. So in this formula here, I want to use 40.4 as my p in my denominator. So my denominator here, we have 0.4, 1 minus 0.4, all over 130. So if I crunch that out, I should get 1.86. And then again, this is a z, so z is equal to 1.86. So if I go to my z table and I look up this in my margins, since this is a z-score, I would find that the percent of z equals 1.86 is equal to 0.9686. Now I need to ask myself, is this my final p-value? Well, we need to go back to our hypothesis and we need to see what is the symbol used in the alternate. Well, here we have not equal to. So that means I need to do my p-value is going to be equal to 2 times 1 minus the percentage that I got here. Since not equal to is a two-tailed test, we need to subtract from 1 to get our one tail, and then multiply by 2 to get our two tails. So this is 0.0628. And so that is our final p-value. And so let's go back to the problem and see what was alpha. Well, alpha was 0.10. So in this case here, our p-value is less than alpha. So then we reject our null hypothesis. So now let's actually go back and write this in the context of the problem. So we would say, in the context of the problem, at the 0.1 significance level, we can conclude that there is enough evidence to suggest the percent of U.S. authors is no longer 40%. So because our null hypothesis was rejected, we've concluded the alternate, and we say that there is enough evidence to suggest the percent of U.S. authors is no longer 40%. All right, so following this model, let's go ahead and complete our practice set. If you have any questions, please join my Zoom call at 8:20, and please submit the classwork by 5 o'clock today. All right, have a great rest of your day, everyone.